Hey guys, welcome back. Have you ever wondered what makes systems stable and reliable? Monitoring is the key that helps engineers identify issues before they become disaster. So in modern world, we aim to make systems as intuitive as human when it comes to health. So let's say we are not feeling well. We try to consult doctor before the thing gets worse, right? So the same principle applies to modern computer system. We try to observe the health of the system, define some threshold, and react accordingly when the things are not working correctly. So the idea is to recover the system as fast as possible before the things get worse. So here is a high level workflow which we use as an engineer to enhance the stability and reliability of a system. The very first point is we collect data point periodically or metrics that define system health. Then we visualize those information to have a high level overview of the system state. Then we set up alert to notify team in case of failure. So this is a proactive monitoring. Then we investigate the root cause by analyzing logs, metrics, or traces when the problem occurs. Once we know the problem, we try to fix it and ship the solution to the production system. So that's the whole process. So what's the core idea? Make the problem visible and observable. So it's actually building stability step by step. So here is an example of a healthy dashboard. As you can see, it's very crystal clear that within the last 15 minutes the system is pretty stable, right? I don't have to give you any explanation here. So at the bottom you will see HTTP request distribution over time. On the left hand side you will see CPU utilization, which is completely boring, and on the right hand side you will see whether the application has restarted or not. So this is an example of an unhealthy dashboard. As you can see, it's very crystal clear at some point in time the system was unhealthy, but it recovered automatically. So the things are not as bad, but it's okay. So it's not as severe, right? So that was the high level overview which I will be teaching you in this course. So then comes the question, what tech stack will I be using? So there are very many tech stack available, for example Datadog, Grafana, but I will be focusing on Elasticsearch, precisely Metricbeat and Filebeat with Elasticsearch and Kibana. The reason behind is I have hands-on experience and I have used this in production systems, so I know, and I will be sharing the things which I have learned over time, what are the best practices, what mistakes which I have made in production systems, so that you can learn from my experience. So what you will learn in this course, first I will start with the fundamentals, so you have a basic understanding about monitoring and how to choose the right system metrics. Then I have prepared different use cases which help you understand how you actually collect metrics. For example, considering most popular systems like Nginx, Ansible, Postgres, MySQL, etc. Then comes what's going on behind the scene. So when you are running system in production system, it's crucial that you understand the system actually. So here I will be sharing some of the best practices which I learned while running the production system cluster. For example, where and how metrics are stored, when you have a big data, how to handle it, what's the retention period, what's the good way to manage data. Then I have created a capstone project. So it's actually a project that mimics real world production setup. So let's start with the fundamentals. What is monitoring? So it's a process that periodically collects data points or metrics to get insight about health or performance of a system. As you can see again here, it's a request distribution over time, so it seems like the system is pretty stable. So the most important part in monitoring is monitoring tells you what but not why. What this mean? This means monitoring just tells you what's not working, but it will not tell you why it's not working. Let's imagine you have a REST API that returns internal server error. There could be numerous reasons why it returns internal server error. Maybe the database is down. Maybe it's struggling with high CPU utilization. So there could be any number of reasons, right? So monitoring system will tell you just the system, what's not working. The why, the possible root cause, is something different. It's not part of monitoring. I have already explained you in the very beginning, in the basic workflow. So then comes the rule of thumb. Whenever there are problems in the production system, investigations are typically tricky. That's actually my experience. So what I have learned over time is that I always use visuals and metrics to have a high level overview of the system state, what's going on, where is the problem. And then once I have a rough understanding, I will try to dive deeper by analyzing the logs or traces, etc. So never jump directly into the logs. That's my opinion, but you may disagree. So here again, it's a recap of the workflow which we have already learned in the previous slides. So the top 3 points is actually monitoring, and that's the focus of this course. So let's start. What makes a good metric? So when I started working on monitoring system, I end up collecting a lot of metrics that does not even define the health of a system. So here the 2 important point is it should reflect system health and it's actionable so that you make informed decision to improve the system. I will give you some examples that may help you understand this point. So the most important and crucial metrics for any system are system metrics. For example, CPU, memory, or disk utilization. It doesn't matter what system you are running, these are universal metrics. Then comes, let's say, REST API, very typical application. Let's say you are running an API inside a Docker container in a AWS cloud, for example. What could be the possible health indicators? Whether the containers are restarting or not, whether your API is returning successful responses, whether your API is responding fast enough, so the request duration. So let's imagine and consider another edge case or another application where you have a publisher and consumer, and you are publishing messages to a queue and consuming messages from the queue. So what's the throughput of the queue? How efficiently the queue is being processed? Whether the size of the queue is under control. For example, you have defined the number of messages which should be processed, let's say within 15 minutes, and it's not processed. So this means that something is broken in the system. So this could be a health indicator. So I believe these examples already help you in understanding how to define a good metric. So yeah, thank you so much for your time. I hope you like this session. If you have any questions, please let me know in the comment section. I will be happy to answer. So see you then. Bye.